In this lesson video, we are looking at domain and range. This is lesson 01. We are going to focus mainly on linear graph and parabola. Let us start. Before we look at examples, we need to know the definitions of domain and range. Domain is set of x values, a range is set of y values. Sometimes it's difficult to memorize this. You might think that domain is y values, range is x values, but then remember this, domain is x values, range is y values. Our first example is a linear graph on top of a Cartesian plane. And then we want to determine the range and domain for this linear graph. Remember we said domain is set of x values. Now looking at domain, we are focusing on all the x values which this graph is covering. Since you all know that these are x values, and then you can see that on top of this x-axis, our graph is there. And then you know that this graph doesn't end here, it actually continues up to infinity. So as you can see, as the graph continues, it's covering all the x values. Looking at the negative side of x values, you can see that the graph is below. So it's either the graph should be above the x-axis or below the x-axis in order for us to say the graph is covering the values of x. The graph also continues. So you can see that from negative infinity to positive infinity, this graph is covering all the x values. So how do we write this? How do we write our domain? We have different methods. The first method, as you can see that this graph is actually covering all the x values. So we can simply say x is the element of real numbers. We simply say that it covers all the values of x. Or we can use inequalities from negative infinity to positive infinity. So x is between negative infinity to positive infinity. And remember, for infinity, it cannot be equals to or included. Another method, we can use brackets. So x is the element of from negative infinity to positive infinity. So this is how we write the domain for this specific graph. Now let us quickly go to range. Range is the y-axis. We focus on the set of y values. So the graph, in order for us to see whether the graph is covering the y values or not, the graph can either be on the left hand side and right. So in this case, you can see that on the right hand side of this y-axis, our graph is there. Then going to the negative side of y-axis, you can see that on the left hand side the graph is also there. So you can see that is the same as our domain. Range, y is the element of all real numbers, or we can say from negative infinity to positive infinity. Remember, when writing this notation, just make sure that on the left hand side is the smallest number, on the right hand side is the bigger number. Or we can use the brackets. this is the domain, actually the domain and the range for this graph. Let us go to the next example. Our next example, we are still focusing on linear graph, but this one is a bit different. As you can see that the graph, the starting point of the graph, it's here. And this point, it's -1 is to 2. And then it goes down up to infinity. So how do we write our domain and range? Starting with domain. From -1, remember it's x values. From -1, the graph is covering all the values from -1. But less than -1, we can see that we don't have the graph anymore. There's no graph. So you can see that the graph is covering from -1, it's there, up to infinity. So how do we write our domain in this case? We cannot say x is the element of real numbers. X is greater than or equals to. It's greater than and equals to -1. So in this case, you are trying to say the graph is covering all the values starting at -1 and greater than -1. So you know that all the numbers this side, all the numbers on the right hand side of -1, they are greater than -1. So we are saying x, it's all the numbers. No, actually the graph is covering all the x values from -1 up to infinity. Or you can write it in bracket form. X is the element of -1. Remember, the square bracket simply means -1 is included up to infinity, positive infinity. And remember, infinity and negative infinity cannot be included. That is our domain. And then our range. Let me just extend this Cartesian plane. We can see that the range, the graph is starting at +2, that is here. From +2 going downwards, the graph is there. So how do we write our range? Y, it's less than or equals to 2. So you can see that from this 2, from this point, our y, it's this direction, it's less than 2. Or we can say y is the element of numbers ranging from, no, remember it's the small number up to 2. That is it. Quadratic graph or parabolic graph. We are looking at domain and range. We start with domain, x values. Is the graph above or below the x-axis? Yes, you can see that this is our graph. It's covering. So from -infinity to positive infinity. So we can simply say x is the element of real numbers. Again, we can say from -infinity x to positive infinity. Again, we can say x is the element of numbers starting from -infinity to positive infinity. We go to our range, y-axis. we can see that the graph is only covering the positive side of the y-axis. On the negative side, we don't have any graph. You can see here, left or right, there's no graph. So it simply means that our graph is covering all the values of y starting from 0 up to infinity. Going up, it's infinity. So y is greater than or equals to 0. 0. How do you put this? No, actually we already did the inequality. So y is the element of numbers ranging from 0 to positive infinity. That's it for this one. Let us look at another example. What about this one? Remember our x values. The graph is covering. So x is the element of real numbers, negative infinity, positive infinity, ranging from negative infinity to positive infinity. That's it. We look at the y values. On the positive side, you can see that we don't have our graph. So our graph, it's on the negative side. So y, it's less than or equals to 0. Y is the element of numbers ranging from negative infinity to 0. Oh no, there's a problem here. It's supposed to be like this. Let us look at the next example. Let us look at this one. We can see that the graph is being shifted 3 units up, 2 units to the left. So what is the domain? Our graph is there. So x is the element of real numbers. And then from there we look at our range. You can see that, let me actually do this. We can see that the graph only covers all the numbers from positive infinity up to this level, which is 3. So you can see that below 3 we no longer have our graph. So in this case, what is the range? The range, we can write it in this form, or we can say y is the element of numbers starting at 3 up to infinity. Now that's it for this lesson video. This is Bahula SJ. Thank you very much.